new file, but then this thing will be lost. Okay, I'll try to write it here, okay? Please bear with me. What Taparel says. My mic kinda trash. Oh, it's okay. Alright, so first of all, think about this, right? The equation, right? In the notes, it says P dot equals to J of theta dot. Right? So J is a matrix that relates joint angular velocity, right? Theta 1, theta 2, to the end effector's velocity. So in that example, theta has two components, right? So this will be theta 1 dot, theta 2 dot. Okay. So what is J? And we saw J is 0, 2, 0, 1 of theta 1 dot, theta 2 dot. And this really means, if you expand this, right, using your knowledge in mathematics, it's simply 0, 2 of theta 1 dot plus 0, 1 of theta 2 dot. Okay, and it says motion of joint 1 causes motion in the whirl y direction. So if you have, let's say theta 2 is 0, right? Theta 2 dot is 0. That means joint number 2 does not move. But then you have non-zero. Let's say theta 1 dot is 1 radian per second. That means the angular velocity of joint number 1 is 1 radian per second. From this equation, you can see that your end effector, or the point P, will move 2 meters per second in y direction. Okay, let's check. Is it true? Look at this, right? If theta 2 is stationary, it does not move. If theta 1 is, it moves 1 radian per second. Indeed, the end effector will move in the y direction, positive y. And it is clearly shown by the equation right here, like what I've shown here. Right? If theta 2 is 0, this thing will be 0. If theta 1 dot is 1 radian per second, so P dot will be 0, 2. So there will be a motion in the y direction, and the value is 2 meters per second. Okay? Alright, good. So more generally, nu is, in this example, because we only considered P, right? P is position. So if you take derivative of P with respect to time, you get translational velocity. But in an actual three-dimensional robot, or robot that operates in three-dimensional space, nu is our spatial velocity. So it has three translational velocity components and 3 components of angular velocity. Remember, we call this spatial velocity, right? And this relationship is sometimes referred to as the instantaneous forward kinematics. Okay. So at this point, you have to know that the Jacobian matrix, it relates joint angular velocity to the spatial velocity. So for a realistic three-dimensional robot, the Jacobian matrix can be computed. This one is just an example, okay? This one is just an example for a two-dimensional robot, right? It has 2 links. But for a robot that works in three-dimensional space, the expression for the Jacobian matrix. The Jacobian matrix can be computed by this equation. So we have to start with, we have to know the homogeneous transformation matrix of the n effector with respect to the base coordinate frame. So the expression for the n effector's coordinate frame for an n degree of freedom robot with respect to the base coordinate system is given as this. So can you remember this? Where did you see this? In chapter 4, right? This is Tn of 0. And we obtain this by multiplying T1 0, T2 1 up to Tn n minus 1. Okay. We know that the top left 3 by 3 submatrix is the rotation matrix that represents the orientation of the n effector with respect to the base coordinate frame. This top right 3 by 1 vector is the position of the n effector with respect to the base coordinate frame, and the last row is always 0, 0, 0, 1. So this part right here is normally a function of the joint angle. So px is a function of theta 1 up to theta n. Okay, let me quickly show you. I think we covered that in chapter 4, right? So I'm opening slides for chapter 4. Look at this, right? This is so this is chapter 4, and this is for Puma 560, if I'm not mistaken, right? And look at this, right? T30 and T63. If you multiply these two, you will get T6 of 0, and the position vector will be functions of theta 1 up to theta 6. Right? So that is what's shown in this slide, right? So from here, you have to compute, in order to compute the Jacobian, you have to do this. So you have F1, F2, F3. So the first row takes partial derivative of F1 with respect to theta 1 up to theta n. The second row takes partial derivative of F2. The third row takes partial derivative of F3. Okay, and the remaining 3, so it will be a 6 by 6. So if you do this for Puma 560, which has 6 degree of freedom, the Jacobian matrix will be 6 by 6 matrix. This is rotational matrix R00. R00 is identity matrix. R10 comes from here. This is R10, right? The top, the rotation matrix. And you have to compute up to Rn minus 10. And if you notice, we have I3 here. I3 is always 0, 0, 1. So this is how you compute the Jacobian matrix for an n degree of freedom robot manipulator. We will see some examples shortly. So, anyway, do you have any question up to this point before I proceed? Would you like to take a break or something? It's 12:10 now. Do you need a break? Okay, Farah is fine. Nurhayati? Okay, how about Alif just now? Alif, are you still there? Was it Alif? Okay, yes, continue. All right, everyone says continue. Good. So this is an example to compute the Jacobian matrix of a 3 degree of freedom robot arm. So we have the homogeneous transformation matrix for 3 degree of freedom robot. So we have T10, 21, 32. Okay. We have to determine the robot Jacobian matrix. So if you, this is the formula, okay, this is the formula or the equation for Jacobian matrix. Let me okay, so this is the formula, right? And this is the question. Where's the question? This is the question, right? Up to here. So you have to know, so what do you have to do first in order to compute the Jacobi matrix? From the formula, we can see that you need F1, F2, F3. Where do you get F1, F2, F3? You get F1, F2, F3 from Tn0, right? Tn0. You have here, we always have 0, 0, 0, 1. So here we have 3 by 3 Rn0. So this is F1, F2, F3. Okay, so you need to compute this. You need to have this in order to compute dF1 theta 1 and so on. So first step, you need to compute, well, not the first step, but you need to have Tn0. Alright, and look at this. You have, so R00 is always identity, like I told you earlier. The rotation matrix of coordinate frame 0 with respect to itself is identity. Okay. You need to know R10, R20 up to Rn-10. In our case, in our problem, we have 3 degrees of freedom. N is 3, right? So you need to know R10, R20. Okay? Because N is 3, 3 minus 1 is 2, 20. Alright. So you need to have all this in order to be able to compute the Jacobian matrix. Well, the answer is given here, but let's try to do this without relying on the answer. It will take some time. It's okay. We have till 1 o'clock today, right? All right, no problem. So, but of course, in order to compute, well, you are given this. You are given T10 up to T32, right? Let me just copy this. Okay. So let's compute all this. Let's compute T20. Why do I need to compute T20? Because I'm in the process of computing T30. Okay, and also I need here, right? I need I need R20, which is from T20. So that's why I'm computing this. So we know that T20 is equivalent to T10 multiplied to 1. Okay, so just multiply these two. Do I need to multiply? It will take some time, right? Okay, let's do it anyway. Don't complain. So this is C1, C2, C1, C2, 0, 0, 0, right? And let's do this one. Minus C1, S2, minus C1, S2, minus C1, S2, 0, 0, 0. And the third column is S1. How about this one? A2, C1, C2, A2, C1, C2, right? A1, C1, C2, 0, 0, 0. Okay, let's check so that I don't make mistakes, and then I'll check later. All right, so the second row, S1, C2, S1, C2, 0, 0, 0, minus S1, S2, minus S1, S2, 0, 0, 0, and this is minus C1 cos theta 1, right? So yeah, I hope you know what is C1, C2. C1 is cos theta 1, S2 is sine of theta 2. And the last one will be A2, S1, A2, S1, C2, 0, 0, 0. All right, good. Third row, S2, S2, oops. So basically, let's do it fast, right? So this element here plus this one, right? Plus this multiply D1. So S2, C2, 0, A2, S2 plus D1. Okay, the last one is always 0, 0, 0, 1. Okay, let me quickly check the notes just in case, we never know. All right, looks about correct. Any question so far? So far good, good. So what is R20? This is R20, right? This is R20. Okay. Let's compute 30. T30 is T20 multiply T32. So this one multiply this. Now we will get a slightly complicated, right? So this one multiply this one. C1, C2, C3. Don't think about it, just do it. C1, C2, C3 plus this one minus C1, S2, S3. Okay? Right, next. Minus, I think we'll be running out of space. Minus C1, C2, C1, C2, S3 minus C1, S2, C3. Okay, correct? C1, C2, S3 minus C1, S2, C3. Okay. And then the third element will be this one, S1. And then the final element will be, wow, A3, C1, C2, C3 minus A3, C1, S2, S3 plus A2, C1, C2. This can be simplified if you notice, for example, this one, right? This is C1 multiply C2, C3 minus S2, S3, right? Does this look familiar to you? Probably it's cos 2, theta 2 plus theta 3. Anyway, okay. Let's check the answer. How did I simplify the answer? Oh yeah, I did simplify the answer. Okay. All right. So that is the first row. And we still need to do the second row, third row, fourth row. Okay, let's speed this up. So I'm going to start here now. So this term, this row multiplied this column. So S1. S1, C2, C3, this multiply this, plus this multiply this, right? Minus S1, S2, S3, So this is the second row. And let's go for row 3. So row 3, this one, multiply every column. Okay, so it looks a bit simpler. So this will be S2 C3 plus C2 S3 Okay, there we go. So that's our lengthy computation of D30. So then how do we get this, right? How come this looks simpler? Look at the answer, right? So for example, the last row of course is 0, 0, 1 is correct, right? But look at this. So we got S2 C3 plus C2 S3. How come the answer here is S23? What is S23? S23 is, so let me just put a remark here, right? What is S23? S23 is sine of theta 2 plus theta 3. And can you remember the identity? Is sine of sine theta 2 sine theta 3 plus cos theta 2, sorry, sine cos sine, right? Sine theta 2 cos theta 3 plus cos theta 2 sine theta 3. So this is the trigonometric identity. Okay, and the same thing here. So if you notice, what is this, right? So let us try to simplify this. This one you can substitute C1 out, so you'll be left with so here we can factor out C1, so you'll be left with C1 multiply C2 C3 minus S2 S3. And if you remember your trigonometric identity, cos A plus B equals to cos A cos B minus sin A sin B, right? So this becomes cos 2 3 cos, this is cos theta 1 multiply cos theta 2 plus theta 3. Okay, so that's why we have here, see, cos 1, cos 2, 3. All right, so similarly, you can do the other simplification as needed, or if you don't want to do it, it's okay, no problem, just leave it as it is. All right. Any questions so far? All right. Now let's gather what we have computed so far. Okay. Well, I think it's easier for me just to continue from here, because I don't have space. It's difficult for me to show it to you. Perhaps I need to stop using sketchbook, I think, because the space is quite limited and I cannot open multiple windows. That's the worst part. What is page setup? You can change the page size. Okay, that's true. Let's make this okay. Let's collect F1. What is F1? Okay, F1 is from our calculation. This one, right? So we have A3, C1, C2, C3 minus A3, C1, S2, S3 plus A2, C1, C2. Okay. What is F2? F2 is this part right here, right? It's A3. Okay, so of course you can perform the derivative as needed. This part, even by using this, okay, but just to check with the answer, let's try to simplify this. Okay, you don't have to simplify in the exam, okay, but I just want to check with the answer right here, just to make sure what I did is correct. Okay, let me try to simplify this as quickly as possible. Okay, so okay, that looks about right. How about this? S1 A3 C 3 S1 A2 C2 S1 A2 C2 S1 A2 C2. All right, that's correct. Okay, something's wrong here. row number 3. Okay, this is a mistake. So row number 3 is, so here A3 C3 S2 multiply A3 C2 S3 multiply A2 S2 plus D1. There should be a plus here. Okay, please correct that in your notes if you have. Okay, right, so now we have this. We can compute, we can proceed to compute df1 d theta 1 up to df1 d theta 3 in our case, right? So from here, let's compute del f1, or to make it the same as the notes, df1 d theta 1. So what is this? So this is a3 cos becomes sine, right? Sine 1. This part remains plus minus a2 sine theta 1 cos theta 2. Let's quickly check with the answer. Okay, so this part here is df d theta 1, right? So minus s1 minus s1 a2 c2 minus c23, right? Correct? df1 d theta 2 now is, again it becomes minus a3 okay. So if you want to simplify this, like in the notes, you can also do this this way, minus c1 a2 s2 plus a3 s2 3. Let's check quickly just to make sure we are on the right track. Minus c1 a2 s2 plus a3 s23 s23, right? Next, df1 d theta 3. Okay, good. And I think I will leave the rest as your exercise. Okay, so you should compute next you should compute this. You should compute df2 d theta 1 df2 d theta 2 df2 d theta 3. You also have to compute df3 d theta 1 df3 d theta 2 df3 d theta 3, right? So make sure you do that, and make sure your answer is the same as what is given here in the answer. All right, and remember in the formula of Jacobian matrix, you also have to compute this part right here, right? So the rotation matrix multiplies 0, 0, 1. So if you refer to the answer, so if you look at the answer, right? So we have computed these two. Okay, please check and compare with this. So R00 is identity, like I told you. R10 is from here, this 3 by 3 rotation matrix. So compare, right? Compare R10 and this one. Should be the same. This is given in the question, right? So C1 S1, 001 S1 minus C1 0. And then you need to have R20. So R20 is what we have computed from here. So this is R20, C1 C2, S1 C2, where is it? S1 C2, S2, C1 minus C1 S2 minus S1 S2, C2, S1 minus C1. Okay, these are R20. So when you multiply I3 is 0, 0, 1, which means you only extract the third column. So you'll be using 0, 0, 1 here. You'll be using S1 minus C1 0 right here, and S1 minus C1 0 right here. And there you go. This is your Jacobian matrix. Okay, so I think I better stop now. It's close to 1. So can you please go through so I will upload this video on e-learning. I think I have to break this video into a number of parts, because e-learning only takes in 250 megabytes of video, unfortunately. So I need to break down this video into a number of parts. I hope I can do that by tonight. I need to go to FKE, I need to enter the campus shortly. So please, in your own free time, if you have time, right, or else we can do it during our class time, please go through this example once again. Please go through what I've shown you here, all right, and make sure you get the answer as shown here. Okay, so if you don't get the answer as shown here, please ask me in the next class, and I will be glad to show you the derivation. Okay, so if you have any question, you can ask me now, or else that's all for today. You may leave the meeting room. All right, thank you very much. Thank you. Thanks.